Hi everyone and welcome back to NTE. So I was asked recently to do a little bit more of financial maths questions, right? So I thought that maybe let's just do the November 2019 question, right? And this is question number 6 from November 2019. So one thing you need to know about the structure of financial maths in your exams is that they are still going to test you about knowledge that we know from grade 10, right? So that's your compound interest formula, your depreciation, all those basic things, right? You can still be tested on that, right? And then obviously, on top of that, you are going to be tested on annuities, right? So your present value and your future value annuity, right? Nice thing about that is that the formulas are on your formula sheet, but of course it's always advised that you know the formulas off by head, but the future value or the present value formula can trick you up, especially in the signs. So you are more than welcome to just, refer to the formula sheet if you need to, right? You just need to know when to use what formula, right? And just read your questions very carefully. So let's just go through this one very quickly. Right, so for 6.1, right, we have two friends, okay? Kuda, if I'm saying that right? So Kuda and Tabo, right, each invest 5,000 Rand for a period of 4 years. Kuda invests his money in accounts, right, that pays simple interest, right? So that's very important. So these are the keywords that you need to be looking out for, right? So Kuda's account is paying him simple interest, right, at 8.3% per annum, right? So he only gets his interest once per year, okay? At the end of 4 years, right, he will receive a bonus of exactly 4% of the accumulated amount, okay? So what's happening here in Kuda's situation, right, you have to imagine the scenarios out, right, is that he's putting 5,000 Rand into a savings account, right? And he's putting this 5,000 Rand away for a period of 4 years, right? Every single year, right, he gains interest, right? Now, this specific bank that he's working with is going to reward him at the end of the 4 years, right, by giving him a bonus 4%, right, on whatever the total amount is of his savings at the end of 4 years, right? So that's basically what's happening with Kuda's situation, right? Now, Tabo, on the other hand, right, he invests his money in an account that pays interest at 8.1% compounded monthly, right? So now we obviously know that because Tabo is getting compound interest, he's going to accumulate money much faster than what Kuda is, right? But Kuda does have that extra bonus, so we never know, right? It's all going to come down to calculation. Okay. The question is very simple and quite obvious, right? Whose investment will yield better returns, right, at the end of the 4 years? And obviously you need to justify your answer with an appropriate calculation, right? So we are going to set this up by considering these two friends individually, right? So we'll do a calculation for Kuda, right? And then we'll do a calculation for Tabo, right? Let's start off with Tabo's calculation because his one is quite straightforward, right? He is going to accumulate a certain amount, right, after 4 years. So he's getting compound interest, so we just need to use the compound interest formula. We've got P 1 plus I to the N, okay? Now, what is his principal value? What is he starting off with? Well, he's starting off with an amount of 5,000 Rand. Yeah, that's going to be 1 plus, right? His interest is 8.1%, right? We need to write that as a decimal, so I believe it's going to be 0.081. Okay, and then we need to divide that by 12 because it's compounded monthly. Okay, and he's going to do this for 4 years, right? And in that 4-year period, he's going to get interest 12 times. So we need to times that by 12 as well. Right. Taro is going to have 6,905 Rand and 71 cents. Okay, so that's Taro. Right. Now let's move on to the other friend. Right. Now remember that he is gaining simple interest. So we need to use the simple interest formula, right? And that's going to be A is equals to P into 1 plus I times N. He also invests the same amount of 5,000 Rand. That's 1 plus, well, his interest is 0.3%, which is going to be 0.083, right, per annum. So we're not dividing this by anything, right? And he's going to do this for exactly 4 years. Right, so that works out to be 6,660. Okay, so 6,660 Rand. Okay, that's how much he accumulates at the end of the 4-year period, right? But remember that his bank promised him 4%, right, off the 6,660. So we need to work that out. Right, so he's going to get a bonus amount of 666.40 cents, right? So 66.40 cents, right? So this is his bonus amount for keeping the money in the savings account for the period of 4 years, right? So then therefore, right, in total, Kuda will receive the total amount of his investment plus his bonus, and that works out to be 6,926, right? So 6,926.40 cents, right? So remember that we were not really asked for these amounts. We were asked to make a decision and to justify it. So we need to answer the question, whose investment yields better returns, right? Well, we can see that at the end of the day, right, even though it's not by so much of a difference, but 6,926.40 cents is greater than 6,905 Rand and 71 cents, right? So then therefore, Kudo, right, or Kudo's investment yields better returns. Right? Because at the end of the day, he receives more money, right? You might look at it and be like, it's not that much of a difference, but nevertheless, he receives more money. Okay, right, so on to question 6.2, right? So now that you've been tested about your grade 11 work, right, which is your compound interest and all of that, you can now actually expect that what they're going to move on now to, right, is your annuities, right, because they have to test you on both those things. Okay. It says that 9 years ago, right, a bank granted Mandy a home loan of 525,000 Rand. Okay. This loan was to be repaid over a 20-year period, right, at an interest rate of 10% per annum compounded monthly, right? So we already have about 4 keywords over here, right? The first thing we are told is that Mandy took a home loan, right? So we know that we're going to be working with our present value formula, and she took a home loan, right? She received an amount of 525,000 Rand, right? Her repayment period was 20 years, and her interest is 10% compounded monthly. Now it says that Mandy's monthly repayments, right, commenced exactly one month after the loan was granted, right? And that is normal, okay? Basically, you need to understand the fact that the annuity formula, right, only works when there is a 1 month gap between when you received the money and when you start your repayments, right? There always has to be that 1 month gap, right? So now usually loans are repaid monthly, right? So we are generally just going to be talking about a 1 month gap, right? It's hardly that you're going to see a loan being repaid weekly, right? But even if that was the case, right, you would still need that gap, right? That 1 week gap, okay, from when you receive the loan to when you start repaying. Okay, so that gap is just to help, or it's there so that the annuity formula can actually work, right? So 6.2.1, right, then says that Mandy decided to make monthly repayment of 6,000 Rand instead of the required 5,066 Rand and 36 cents, right? How many payments will she make to settle the loan, right? So what Mandy is doing is actually quite smart, right, and actually recommended, right? It's not going to be recommended by the bank, okay? So if you go to the bank, you actually take out a loan, they're not going to advise to you, right? The person in front of you, your consultant, is not going to advise to you that you pay more than your monthly repayments. Okay. And the reason why they won't do that is because they want to keep you as a customer for a longer time, right? Because if they keep you as a customer who is repaying this loan for a longer period of time, they gain more interest from you, right? Instead, what most people do, right, which is an example of what Mandy's doing, okay, even in future when you actually take out a loan, right, if you are able to pay more than what the computer calculates as your monthly repayment, do that, right? Because then what you're doing is you're cutting down the amount of interest that you're repaying, right? And you're also going to pay off your loan much faster, okay? I do know somebody who was able to repay their home loan, right, within a period of 8 years instead of the required 20 years. Okay, so just a piece of advice that we learn from financial maths, right? Because at the end of the day, we do financial maths to help us to make decisions in the real world, right? And the situations that we cover are also real world examples, right? So one of the tips that you can get from this situation over here, right, is that when you take out a loan, always try to pay more than the required, right, monthly repayments, right? You can obviously not pay less than the monthly repayments, right? So, for example, if your monthly repayments are, as stated for Mandy, 5,066 Rand, you can't pay 4,000 Rand. That's not going to work, right? Otherwise, they're going to charge you extra interest, okay? So you always have to pay exactly that amount, or if you can, always pay more, right? So what we have to do here with question 6.2.1, right, is to calculate how many payments, right, and payments of 6,000 Rand is she going to make, right, in order to settle this loan. Okay, so in other words, we are going to be calculating for the variable n in our present value formula. Okay, so let's jot down the present value formula. So we know that she got a loan, right, which was an amount of 525,000 Rand. She decided to do monthly repayments, right, of 6,000 Rand. And then we have 1 minus 1 plus. Her interest was 10%, okay, so that's going to be 0.1. Okay, and then where am I now? Right, so we're going to divide this by 12 because it was compounded monthly. Right, so now we're going to get to this n over here. Right, now remember that this n is representing the number of payments that she's going to make. Right, so she's making payments every single month, right? So which means that the value that we're going to get, right, for n actually represents the number of months, right, if you want to think about it that way as well, right? So we're going to be calculating this n, right? Then we're going to divide this by her interest, which is the 0.1 divided by 12. Right. So now it's just a matter of rearranging this equation very carefully, right, and solving for n. Okay. So obviously the first thing we're going to do is we're going to multiply both sides by the interest. So then once we've done that, that's gone, right? We're left with this big bracket, right? So we're going to divide this by 6,000 Rand. Okay. Now that's now going to be equals to 1 minus this whole bracket. Okay. So then we can subtract 1 from both sides. The 1 will disappear from here and show up on this side. And that's going to be all equals to negative 1 plus 0.1 divided by 12. All of this to the exponent negative n. Okay. So now all of this, right, on the left hand side has to be divided by negative 1. Okay, so let's work out what this value comes out to, right, the value on the left hand side. Okay, so this works out to be, right, 13 over 48, right, we'll just write it down the way it is, right, so 13 over 48. Okay, that's now equals to 1 plus 0.1 over 12 to the negative n. Okay. Now, what you do over here is your choice, okay? You can log both sides, or you can change into logarithmic form, right? So if you want to log both sides, then you're going to have the log of 13 over 48 is equal to the log of 1 plus 0.1 divided by 12 to the negative n, like that. Okay, so then you have log of 13 over 48. Right, that exponent, this one, can move to the front there. Okay, so then this is equals to negative n, right, times the log of this entire bracket. Okay, that's one way, right? Going from this step, right? So from this step, if you wanted to change into log form, right, then what you would do is you would say, okay, log of this base, right, so there's your base, okay, so log of this specific base of the number 13 over 48, right, it's going to be equals to the exponent of negative n. Okay, so that's changing into log form, and this is logging both sides. Okay, and this works out to be 157 payments, right? 0.402 something, 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 right? Now, these decimal points over here, believe it or not, the bank actually still charges you for all those decimal points. So now remember what we were asked. We were asked how many payments does she need to make in order to settle the loan, right? So in order to settle the loan, okay, she's going to have to make these 157 payments, okay, plus 1 month's extra payment, okay, which is due to these decimal values over here, okay. So it's actually 158, okay, but we write it out this way, okay, we write out that number plus 1 month's payment. Okay, right, let's just check how you would evaluate n using this method, right, where you changed into log form. Okay, so you would go into your calculator and you would choose this log function, right, which allows you to input your base and your argument, right, so your base in this case is this bracket. Then your argument is 13 over 48. You press equals, you see you get that negative sign right over there, right? You can obviously not going to have negative payments. That's why you have that negative in front of the n there. You then divide by your -1. That gives you the same n value. Okay. Okay, so now let's move on to question 6.2.2, right? It now says that after making monthly repayments of 6,000 Rand for 9 years, right, Mandy required money to fund her daughter's university fees. She approached the bank, right, for another loan, okay? But now, instead, the bank advised Mandy that the extra amount of repayments that she's been making each month, these can now be regarded as an investment by themselves, right? And that she could take that money, right, withdraw it out, and use that instead to fund her daughter's studies. Okay, so now we are asked to calculate what is this maximum amount, right, that Mandy will be able to withdraw from the loan account. Okay. Now, if I can just put this into perspective for you, right, what's happening now, okay, is that it's now 9 years later. Okay, so she got the loan 9 years ago. Okay, so it's now 9 years later, right? And Mandy's going back to the bank, right, and is asking to open or to take another loan, okay, to fund the daughter's university fees. Okay, but now the bank goes like, we got you, right? You were trying to run away from us, okay, because she was paying extra on her loan, right, which means that we're going to lose her as a customer much faster, right? So the bank was like, we got you, right? So instead, what we're going to offer you, right, or advise you to do, okay, is that don't open another loan, okay? That's going to be too much of a burden on you. Imagine now you're going to have to be repaying 2 different separate loans, right? Instead, use the extra amount, right, that you've been paying, right, and that can actually be regarded as a investment, right? And why can it be regarded as an investment? Because that extra amount is constant, okay? She was paying this extra amount on a constant basis over these past 9 years, every single month, okay? So that extra amount, right, can act as its own annuity, right, which is a future value annuity, right? So the reason why the bank is doing this, it's quite sneaky, okay? Because at the end of the day, it's a win and lose situation, right? But in reality, this is usually the best way to do it, or sometimes it's kind of like the only option you have unless you are somebody with a lot of money, okay, and you are able to afford paying off 2 loans, right? Obviously, you don't have to accept this offer if you don't have to, okay? But this is one of the offers that the bank is going to make you, right? The reason why they're making you this offer, right, is because they want to keep you as a customer for the entire period, right, of that initial loan, okay? Because now, when she withdraws this amount, okay, she basically goes back to square one, which means that they still have her as a customer for the next 11 years, right? That is if she doesn't carry on paying more than what she's required to pay, right? So either way, now she's basically, well, then we're not told whether she's accepting this offer or not, but we now need to calculate what is this maximum amount, right, that she can actually withdraw from the loan, okay? So this is where you have to just think very carefully, right? You need to understand the fact that, well, over these 9 years, okay, she's been making payments every single month, right? So when I times that by 12, okay, that works out to be 108 payments. Okay, so now we're going to have to look at the monthly repayments, right? So the X value for her future value annuity now, right? And that monthly repayment, okay, or monthly deposit, right? Yeah, let's rather say monthly deposit, right? This monthly deposit is going to come from the difference between what she was paying and what she was required to pay. So she was paying an extra 933 Rand and 64 cents. That's a lot of money. Okay, so 933 Rand and 64 cents. Okay, so now change your thinking, right? Now what's happening is that this amount, okay, imagine that she was actually depositing this amount, right, for the past 9 years, every single month, right? So what is her future value? Okay, so into the future value formula. So now the maximum amount that Mandy can withdraw is going to be given by this fraction over here. Okay, and this works out to be 162,503 Rand and 51 cents. Okay, so that's the maximum that she can withdraw from her loan. Right, now obviously the decision is going to be up to her. If this amount of money actually covers her daughter's studies, then obviously she's going to say yes. Okay, but if it happens that this amount of money does not cover her daughter's studies, she can take it out and then take out another loan to cover the difference, or she can decide not to take this money out and just take out another separate loan that covers her daughter's studies completely and just pay off those two loans simultaneously. Right, so that's her choices here. Okay. So then that's it for today's video, matriculants. I hope you learned something, and I will see you guys next time.